Alright, I'm doing a video to kind of just go through this document, and mostly for my own purposes, to just see if it makes sense to me, and provide a further explanation for people who don't understand something in some sort of way that I don't understand why they don't understand. And so maybe I will say something to clarify what's being stated. So anyway, starts off the theory of everything. So this is essentially one of these unification type deals where you come up with a mechanism that can be applied to all the subdivisions, so to speak, of physics, in the sense that there's one component of function, and it manifests in different ways, in different conditions, and in different complexities of systems, but you still have this fundamental quantum element, this fundamental element that will always be conserved, and something like that. So the abstract. At some point in the early 1900s, the science of physics committed itself to a confused dualism model of reality, where things could be more than one thing. The controversy of wave versus particle became the compromise of particles waving, and with that physics waved goodbye to a rationally comprehensible model description of material reality. So fundamentally, back in the 1900s, they had this young double-slit experiment, and based on the results, consequences, there was proposed, because it matched the mechanics of water waves, that photons have a wave element, that there's some element to a photon that is actually projecting some sort of force. That force interacts with itself in some circumstances, or with other photons, and then the photons do something based on that wave interaction, and they change their direction based on this interaction. And there's no other evidence of photons doing any of that. I mean, light from light bulbs reflected all over the place. You can't really find any evidence that light bounces off of itself or each other, photons. They can be scattered by particles in the atmosphere, but they can't be scattered by each other. You can shoot light into light all you want, and you won't be able to make it bounce off of the light. So in spite of that fact, physics committed itself to this idea that under some circumstances, this wave property of photons made photons bounce off of each other, in a sense, be deflected by each other, change their course based on interaction with each other, this kind of thing. And this then precipitated the development of quantum mechanics, which is basically a description, in some sense, the mathematics of phenomena that does exist. It's just that their explanation for the existence of it is based on this idea that photons are waving. I won't get into all that. Einstein at first didn't like the idea of waving particles, but he became somebody who could bend space, so, you know, his objection doesn't mean too much in that context. I contend that the particle theory of reality was correct. So the argument is that they would have stayed with the idea that let's try to find this quantum particle. Let's find the smallest thing and see what it's doing, and see what it's part of. And they sort of left the building, so to speak, of recognizing force and interaction is based on some sort of quantum of a photon, a ton of some kind, and created this entity that was a wavy ton, some perturbation in some ethers of some kind, like bent space, kind of an ether. Was correct, and the science of physics needs to return to the post-Newton, pre-Einstein knowledge base. So basically just arguing that get rid of this idea of a waving photon, and understand that photons interact with matter, that matter has fields. Those fields can bend photons, as we know they do in prisms and other mechanical devices, and it's just a mechanical function of photons interacting with matter. and realize that we don't need to bend space and time, create fake dimensions and fake places to answer the questions of why things happen the way they happen. And also explains the energy dynamic and all of that stuff. So anyway, obviously I don't say that in here, but that's the implication of the statement. Is post-Newton would be raw physical kinetic mechanics. Pre-Einstein, that would be that. And Einstein would kind of define the point where the development of wave theory and bent space and bent time was invented. And those concepts are all abstractions that are essentially a cheat, in the sense that they manufacture energy like for gravity. Instead of explaining where the energy for gravity comes from, they just create a fake dimension and make the fake dimension produce the energy of creating slopes for the matter to roll down, so to speak. And it's just incorrect. There is no energy dimension of space or time. Alright, so it is posed that the universe in substance is just made of one thing. Let's call them quantons. This image should kind of just spell it out. They're things moving in a direction at the speed of light, generally speaking, and they don't do anything else. They don't split in half, they don't move slower, they don't move faster, they just move the speed of light in a direction, and they bang into each other and exchange direction. The one going this way will end up going that way, and the one going that way will end up going this way, and that's it. They exchange direction, period. Anyway, they're always moving and have no other property beyond orientation or polarization, which simply just means they have a flatness. So they can come at you this way, or they can come at you this way, and they can come at you across this way, which really won't be at you. Yeah, that's something I didn't, well, I won't get into it now. I'll just read what's written. Don't go too far. These quantons fill space, matter, and energy, and are, in essence, all there is and all that is. So that's pretty direct. Everything's just these little bits. Your atoms are made out of them, your protons, neutrons, electrons. Every ton, every quark, everything that exists is made of these things. Alright, these quantons, okay, I did that. When trapped in circular orbits, we call them matter. Maybe I'll put the word swirls in here next to orbits, because it's really about hurricanes, not single items orbiting. It's not a solar system that's inside of you. Alright, one proton has what? I don't know, a million of these little arrows in it. An electron, maybe 10,000, some kind of numbers like that. 1,000, whatever the limit is. I don't know the total number. I mean, you're just talking about a ton. There's a lot of energy in the neutron, proton, and electron if you quantize it into photons. When they have their anti-photon crashes, I mean their anti-electron crashes into their electron, it releases all photons. So we know some of these equations. So I'm just saying, however many photons that creates, we just cut it in half and say the average electron has that many photons in it. These things, gravitons, are quantons. They're all tons, and they're all made out of one ton, but it just depends on whether the ton is, well, I'm going to explain that. So, alright, so we get this. When trapped in circular orbits, we call them matter. So, just when they're in the swirl thing, that's matter. That has mass, because it has a direction in all directions in that dimension that it's spinning in. It's moving in all of those directions, and it has technically a mass. You can think of mass, a really simple way to think of mass is just think about something moving, like a bullet. A bullet would have mass in the one direction, that is the direction coming at you. The rest of the directions, it really technically has no mass. Has no weight. Okay, you couldn't weigh it. The direction that matters is the direction it's moving. And so circular orbits are essentially multi-directional photons in a sense. And so they have what we call mass because they are conserved. They go up as much as they go down, left, right. Alright, when they arrive at a precise time interval, we call them light, photons, electromagnetic radiation. So you have this whole spectrum of radiation from radio waves to cosmic rays, and light somewhere in the middle, and they run at a frequency. And so, unlike this wavy thing with electro components going one way and magnetic components going another way, a photon is just a little one of these arrows, and what it has is polarization. And that's it. And so when it arrives at a orbit, a swirl, it can only be absorbed if it has the right polarization. If two of them come at the right frequency with the right polarization, then they can be locked in the orbit, okay, because they have the right balance. So they have to be balanced to the orbit they're entering. Just as any kind of physical device shot into our solar system would have to enter at a proper trajectory to be accepted by the solar system, so to speak, technically. So a photon is just a frequency. It's just the frequency that these things come. So if there's one here, and one here, and one here, and one here, and they're all separated by the same distance, we would recognize that as some electromagnetic spectrum item. Okay. They are, let's see, okay. When in their most common condition, not matter or energy, they are force and instigate through their ability to transfer directional identity, all material movement, gravity, magnetism, electric charge, nuclear force. This is what the universe is full of. So just imagine, you know, this light is on here, and there's lots of photons flying around. We'll just multiply that by 1 zillion. And that's the number of non-visible tons bouncing around you right now. It may seem impossible, but just think of them. There's so many of them. You can reveal them, say, when you have like a black hole and you have super gravity. Gravity is so strong it'll stretch you into a piece of spaghetti. Well, that energy is already in the universe all the time. It's all the time there. It's just that there's as much force on one side of you stretching you into spaghetti as there is on the other side of you stretching you into spaghetti, so you don't get stretched into spaghetti. So it's only when there's an imbalance in the force that you feel its power. But its power is immense. Its power is revealed in like a nuclear explosion. The amount of movement or activity you see in a nuclear bomb exploding is the amount of activity that's around us all the time. It's just that it's perfectly balanced, so you don't see it. It's invisible to you. There's as much of it's nuking you from one side as it is nuking you from the other side, so to speak. Alright. At the real working level of the universe, the smallest bits are just kinetically banging into each other and exchanging direction. So as I stated before, it's just these little arrows, they bang into each other, they exchange direction, and because of that activity, there are certain inevitable consequences, which are the idea of shadows and all this stuff, but I'll get to that. The fundamental function is that simple, and combined with the property of pattern creation, orbits, the incredible complexity of the universe as we experience is filtered out of this simple function. So it's just this simple function. It will inevitably, because if you just pick one location in here, there's an arrow pointing at it. Let's see. There's an arrow pointing at it. 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 So any location is just a focus of a bunch of arrows. And so there's always a constant pressure pushing you, your surface, in. But beyond that idea of pushing you in, if anything's near you, it'll be pushed into you because there's an automatic low pressure created between you. Because these things don't go around the corner, so there's no evening. So there's no evening out of the pressure because they don't go around corners. They don't fill voids. They do everything in a straight line. So they go over my head straight across. They don't go around and infill in here. So when we interact with each other, the force that we're blocking is all straight line force, and there's nothing filling the void. Obviously we don't have enough gravity, we don't have enough mass to block enough of these tons for us to be pushed into each other in a very aggressive manner. But obviously magnets do have. If you were a magnet, okay, if you were made out of magnetized material, then you would be filtering this energy and you would be sticking to other people inadvertently. Alright. Alright, the kinetic paradox. So this is understanding that these interactions are kinetic, and by kinetic I just mean this simple idea that there is no waste, there's no friction, there's no anything else. All that happens is the interaction, and the interaction is complete. And all it is really is an exchange of direction. So with the kinetic ball swinging back and forth, you can kind of get it. They bang into each other, the other one just takes all of the directionality and force the one had, and it continues the voyage, and vice versa. So the one who's still ends up moving, the one moving ends up still. They just completely exchange conditions. And that's it. That's all these things are doing. Alright, in a pure kinetic interaction between indestructible hard masses with a velocity, I don't know if I want to say momentum, but I'm going to use it anyway, there is created a paradox of sort in that the interaction can look either like something or nothing happens. So the idea is the two things crash into each other, and the outcome is always the same. I mean, there's two things that leave. So, it's like using the head-on collision is the best one, but I mean, two things go in, but the point is two things are going to go out exactly like they would have if they'd never hit each other. But the important fact is they did hit each other, and what they are going to do is exchange some sort of identity. As it turns out, the head-on collision doesn't really do that. So the tangential collision, you will pick up the polarization of the other thing. So this will change your polarization. So if this had an up and down polarization and this had a horizontal polarization, they would leave with the opposite polarizations. But anyway, I don't want to get into that detail. There's so many details to get into. Anyway, viewed one way, the objects will have their velocities travel through each other, and the universe after the interaction will look exactly like it would have if the interaction never happened. Viewed another way, it can be understood that the masses completely interacted and exchanged their directional momentum, and the resulting universe is now substantially changed in that the objects have individually substantially exchanged directions. So it's just pointing out that you can look at it both ways. You can look at it like they go through each other, or you can look at it as like they bounce off of each other. The end result is the same, except the red arrow's on this side and the black arrow's on that side. But clearly two arrows leave with exactly the same trajectories as they went in. It's just that it makes a big difference which arrow is polarized and which one is still moving at a frequency, in the sense that the next one and the next one will all come at that same period. That's why light can't be bent, is because traveling through a kinetic field, frequency would just keep going. You couldn't make the frequency go this way. You can only do that when it interacts with matter. Anyway, orbits. The truth is, the purely kinetic interactions of quanta are a complete exchange of identity. So I'm just verifying up here that this is the truth. Okay, they exchange direction. The quanta, and you know it from the kinetic balls when they bang into each other. Clearly, the moving ball stops and the stopped ball moves. Let's see, the quanta that make up the universe are at regular rates experiencing this change in identity, and this creates opportunity for the collection of identity in patterns and forms, which means orbits. In geometry, a circle can be understood as a rounded square. So this is just the idea that a circle, if you average it all out, right, just by dimensions, by planes, okay, this half, this half, this half, this half, this half, this half, if you do that, okay, you'll come up with a cube, okay, because you can just take this direction gets wiped out by that direction. This direction compensates exactly for that direction, so it's all balanced. So obviously up and down in the square is the same as this side of the circle and this side. Those are even. You have force going up, you have force going down. They're equal amounts of force. The force going across, the force this way is all equal. So in a sense, a collection of 4 90-degree turns. So that's basically what a circle is doing. It's just the circle has a bunch of little turns to accomplish it. But again, if you if you take all the reciprocating ones, all the ones that are reciprocal, you just basically get the dynamic of one up, one down, one across, one across. In a mass of randomized kinetic interactions, it can be understood to be just a matter of probability that there could be 4 interactions in a sequence that might take an object back to its starting point and create, in essence, a circular path. So you can sort of understand that it wouldn't be, it's like getting 4 tails, flipping 4 tails in a row, you know, Democratic primaries. So 4 tails in a row would be, these would all be right turns, you know, 4 right turns, and that would be a circle of sorts. And in the sense, if you think of the pressure always pushing, then once you've established one of these things end up always getting, there's a tendency to preserve it. So once you create something circular, it's like creating a water bubble. It's a little harder to break. So once it's made, it has a tension, you know, that's built in, and a durability that's built in, like, you know, Roman arcs or something. It has an intrinsic strength to the pressure. Okay, in a mass of randomized kinetic interactions, okay, it can be a matter of time. Okay, right. In essence, a circular path. It is a quality of the physical universe which enables such patterns to become durable, that is responsible for all that we know as matter. So all matter is just made of bigger and bigger swirling entities. So electron would be this much swirl, and then a proton would be this much swirl, and a neutron would be this much swirl. Okay, neutrons being bigger than protons. And so you can sort of see that you can create all kinds of models of how those swirls can interact. I mean, I would argue, since we know the neutron is bigger, that people have been, the standard model doesn't get it quite right, in the sense that what's probably, I think, might be happening is the proton is the swirl in the middle, the electrons are little swirls going around that swirl, and the neutron is another big swirl turning the opposite, going the same way as the electrons. So the electrons are going the opposite spin of the proton, but they're going the same spin of the neutron, which is a big swirl out here, a big ring. So they don't even, I don't think they quite have the dynamics of the atom correct, but those arguments I'm not going to make in this paper. And those need to be really scratched out on paper to figure out whether it actually will work. But I tend to think it might. Anyway. It is so the material universe is just quanta in circular orbits. I just basically said that. And as those orbits begin to orbit each other, okay, little electron storms going around, proton hurricane, material structures are formed. In the very big universe, we see a simplicity that is also in the very small universe, but hidden from perspective. So I think that's a sort of an important sentence, is to realize that, you know, if you really look at the universe, the big universe, just ignore this tiny little chemistry, you know, part of the size dynamic, and you can sort of see in the big universe it does just become balls crashing into each other kind of stuff again, and you're back to just big swirly bits, and that's all that's really happening out there. I'm not saying that down there looks exactly like that. I'm just saying it's the same similar force. Obviously on this kinetic level, I'm arguing it's a lot squarer. It's not going to have the rounded corners of the big universe. It's going to be a lot more herky-jerky in the small universe. But the idea is the same. It's stuff spinning, generally speaking. Yeah. Okay. So now on to gravity, I believe. The universal glue, kinetic field pressure. So this is just basically where I'm making this shadow argument. So obviously if the force is coming here in straight lines, you can sort of understand it's all straight lines. The straight line, there are straight line vectors that will hit this surface, but you'll understand that most of these straight lines can't. So there's a whole bunch of straight lines that have to go through this body, this body, to get to this body. So those are all be some portion of those absorb. So if 99 of them go in, 100 of them go in, maybe only 2 of them will get blocked or kept here, but that's 2 less hitting this surface, and so obviously this pressure now is 2 plus 2 compared to this side. So again, back to my nuclear bomb argument, if you have 2 nuclear bombs blowing up on both sides of you, if one of them is stronger than the other, you're going to tend to get manipulated more by that explosion. You don't need to use a force that dramatic, but I think you get it. Alright, in the big universe, we see the mechanism we call gravity hold matter in patterns that make solar systems and galaxies. So you see it out there. Well, it's also happening down there, down the small universe. It's also doing the same kind of thing. It's just that it is a little more mediocre. It's a little more particulated, and so it's got pixels like this screen. It's just little dots. Well, the little dots are big dots in the little universe. So things that happen are a lot more aggressive, all or nothing. Where in our big universe, it gets all the subtlety gets knocked out of it because it's so our interactions are so tiny by comparison. I mean, me doing this. I mean, could we calculate how much energy this is compared to a nuclear bomb? Those kinds of bizarre disproportions in activity. Well, there's no such thing as this in the micro universe. It doesn't do this. It does something or nothing. On the level of the very small, the very same mechanism holds quanta in patterns that become matter. Okay, now it's the same mechanism, but it's obviously now going to be converted through this polarization idea. Which plane things are spinning on will dictate the strength of interactions. And so it's kind of like more magnetic than gravitational, but technically it's the same force. It's amplified when you're filtering it for polarization. So if you're sensitive to bee stings are really, really important. And if you're not sensitive, you're not allergic, who cares? Pretty much. Alright. Just as space between planets is the same as the space between atoms. I think that's another important sentence. I mean, people just don't realize that empty space is empty space. And it's like when they, in the big cosmos, they start creating ideas like space is expanding or doing something. They're saying, well, if it's expanding out there, it has to expand inside the atoms too. You can't pretend that the empty space inside of an atom is different than the empty space outside the Earth. I mean, it's the same empty. There's not 2 different empties. So in a sense, it's one universe. And the smallest planets are atoms. The smallest solar systems, and it's really just a size division, but that's really those are the kernels of it, and it's the same thing going up. It's these little hard bodies interacting, and like the big universe, doing it in a small universe in the same empty space arena. We just can't perceive it that way because our senses are perceiving a much thinner veneer of the game that's going, the real game being played. We're so far from the chessboard that all we see is things with hands moving. We can't really see what's happening. Alright, I don't know. Between atoms, the force holding these things together and pushing them towards each other is fundamentally the same. The universe isn't 2 places, big and small. It is one place with one set of fundamental properties. Okay, so the force holding these things together and pushing them towards each other is fundamentally the same. So I'm using the word fundamentally because, yes, it's still a type of gravity that's holding atoms together, but it's this magnetic gravity. It's filtered gravity, which makes it much stronger. And clearly it's Volkswagen against Volkswagen on the atomic level. It's very in your face, all or nothing, and the all is a quanta of movement. Alright, so big and small, it's all one place, one set of fundamental properties. So That's another key element. The rules are the same in both big, small universe. It's the same game. It's just your ability to see it is different. They are in constant movement. Oh, here. Imagine starting with a clean slate. So let's do this. Forget bent space, forget bent time, forget everything you know the universe is supposed to be, and just play along for a minute. A great expanse of truly nothing. So just make it nothing. Now introduce a simple something, a dense field, and I mean dense, of simple little bits that have a short list of simple properties. So this is where we're making the arrows. Alright, so we're making a ton of these little things. They are in constant movement in straight lines. Well, they're moving the speed of light, but I just don't know if I see. Technically, the question's going to arise is whether their speed is decided by the distance between them, or whether speed or time is decided by interactions. Interactions might take time, and that might be where time is created. So that's why I just don't say the speed of light. They are shaped taller than they are wide, so this is this simple idea. And they hit each other, and when they hit each other, they exchange direction with each other and do nothing else. So that's pretty clear. They do nothing else. So they hit each other, they exchange direction, and, well, clearly they also can exchange polarization. So I guess I can't say nothing else, but they do that too. But the interaction does take a moment of time. So here I'm establishing that the interaction is probably where time comes from, but I can't say that for sure, so I'm left indecisive. Consider the implications of such a field in motion. Perhaps you can understand that it would create a kind of even pressure. So I've sort of already been over this, but obviously the field, this randomized field, is going to have arrows pointed right at me, and those are the ones that are going to be significant. The ones that aren't pointed at me aren't going to hit me. They might as well not exist as far as I'm concerned, but clearly the ones that are going to hit me are going to come from all directions evenly in a big spherical kind of way from every direction and hit me, come through me, interact with me, and that's pressure. Alright, perhaps you can understand that would create a kind of even pressure, that every point in the field would become a point of interaction or convergence. So this is a word they use to describe what gravity is. The professional physicists describe it as a convergence, which means you could think of it as a very flat lake of water that never gets any higher, and that has a drain, and the drain is constantly pulling it out, and it's constantly coming from nowhere to refill what gets pulled out. So it has an unconstructed drain and an unconstructed faucet that keeps it always the same level, and it just, the stuff just moves to the hole, the drain. No friction, no eddies, none of that stuff. It just converges at a point and enters from the field. Effectively bombard in every direction. So, but that's what happens to you, right? So if the external world is always pushing at me, it's the same thing as me having a drain. Well, the opposite would be something's constantly adding water, but it can only add so much water. So the field is as strong as it is, and as long as I don't create a drain, there's no imbalance. There's no activity. But as soon as I create a drain, then there's this imbalance. Alright, effectively bombard in every direction. If you were to place a still object in any position in the field, it would be constantly jostled by pushing force coming from a constantly changing direction. So it's a random thing, in a sense. They don't come in frequencies. There's no pattern to it. So at any one moment, more could be hitting my head than they're hitting the other side, or more get hit from the left than they're hitting for the right. But the next moment, the coin tosses will be more from this side than that side. So it'll balance out in tiny fractions of time. But in any one fraction of time, there could theoretically be an imbalance that, causes me to do this kind of thing. Alright. If you were to, okay, jostled. Now introduce the second still object close to the first. Perhaps you can understand that this single object will be profoundly affected by the other object's presence. So if you add a second object, right, you can sort of get this idea that there originally was just this object, so it had a field of this pressure. And you can sort of understand that when you introduce another object, it has a field of pressure, but that these two objects are now kind of creating a field. Like, you don't get to even pressure unless you put a circle around both of them. Then you have even. But if you don't, you're going to have uneven pressure in these local fields. This local field will be made uneven by this item, and this local field will be made uneven by this item's presence, because these items are going to absorb some of these arrows. And the real absorption is through the acceleration towards each other. So as they accelerate towards each other, they grab this speed of light movement and they turn it into something much slower. You know, when something accelerates, it accelerates much slower than the speed of light. So it's absorbing something, moving the speed of light, converting its speed into a much slower speed. And this is doing the same, and as they keep absorbing these arrows, they keep creating a shadow here. Both items are going to move into that low pressure. I think that's really, I mean, people who know something about physics should know that that's a perfectly competent explanation. Objects will be profoundly affected by the other objects. Now the straight line pressure will not be able to reach each surface evenly. This circumstance invents the shadow. Technically it's not a shadow, it's a, well, it sort of technically is. Like I said, it's an absorption, it's a reduction of something's speed in this sense, right? This arrow is going to hold in here and move much slower, because really what it's doing is converting all of these things into arrows moving this way. But I won't get into the complexity of it. Just understand it. It's moving the speed of light here. It goes inside of this thing, moves much slower than the speed of light. So it's really delaying its getting here. In a sense, it's inevitably going to get there. It's just not going to get there when it should have gotten there. It's going to get there some other time. Alright. Invents the shadow, and with it imbalance, and with that movement. So as they absorb these arrows, they move. Acceleration is born. This is the mechanism. The material universe is pushed together through this mechanism. Not so much by the presence of force, but by the shadow of absence. Oh, I think beautifully written. So that's really the trick, right? Imbalance is the key to this whole thing. There's nuclear bomb mass of photons, the quantons, surrounding me right now. The density is that thick. They're so thick. And it's only when there's an imbalance that I can turn it into anything. I mean, technically, I could be a black hole, and right here there'd be enough force to shove something into me so fast that it turned into spaghetti. You know, so fast that it just ripped it into a tiny thread of matter, because there's that much force around me right now that, you know, I could be creating that much of a low pressure. That's how much high pressure there is, right? You can only define how high the pressure is by understanding the low pressure. So the lower you can go in terms of creating a low pressure that creates an incredible amount of force, then you can understand that that must explain how tremendously powerful the energy is in the field. I mean, we're experiencing, you know, 1/zillionth of the universe's energy. I mean, a tiny, 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 tiny fraction of it is involved in our little photon interactions and our little bit of heat and the little bullshit that we're doing. This little tiny bit of energy activity is a tiny fraction of the activity going on. We're sensing only a tiny fraction of the quanta that every square foot of this universe is full of. Alright, colliding with the technicalities. Okay, maybe I'll take a break and come back to that one. So we'll call this part 1. And such. So, till next time.